the white paper, number one question is going to be treating what I will term the bifilar suspension. And in that bifilar suspension, we are going to be making use of a meter rule and a mass at the center of gravity. We are going to be making use of a retort stand, 2 retort stands, and we are going to be making use of a clamp and a split cock. We are also going to be making use of split cock, a clamp, and these retort stands. We are going to fix it in such a way that it can be easily pulled up. And then it can be allowed to settle well, keep them parallel. You need a paper tape in order to be able to keep this, holding them at the center of gravity. However, the question is going to come, what I'm doing this at this point is not going to be an expo. It's just going to be giving you a guide. And for those people who don't really know what that number one is talking about, it's just going to give you a guide on how you're going to go about it, and which I'm going to do. So at this point, you're going to come with your record, a book to record. You have your phone, you can use it as a stopwatch and whatever. So this is a tension. The meter rule has a mass, and also a moment of force is part of this, because this force is holding it through this thread, which is called a tensional force at this point, or a support or a tensional point at this point, and the mass, the mass of the meter rule and the mass which you are going to hang at the center of gravity will all act together to be the downward force. These are the 2 upward forces, and these are 2 downward forces. This is the 2 downward force, and this is all you need to know about this practical examination. But I will also urge you to stay put as I run you through the whole process of practical. You don't have to do it like this before using your stopwatch to take a reading. It's not supposed to be like this. That's not the intention for this one I am doing. Probably they may tell you to do that. That is different. But what I am doing is not about that. There is an axis of rotation through this center, which is the middle, which is the center, the center of gravity is going to be rotating about the center. This particular one I'm doing. Waec may decide to come up with something different, but whatever they're going to be bringing, we're not going to be far from this. You have your stopwatch, then you are going to be varying the length. And the issue of mass, from the experiment I have conducted, what I realized is that whenever you put the mass on the center of gravity, it helps in oscillation. But it depends on what the question is going to be giving you. But this experiment is actually going to give you a good guide on how you are going to come about it. What I'm going to be doing, not that I have seen the question, not that this is expo, but just to give you a guide on how you can follow this experiment and be at point for it, so that you just don't have to allow them to take you unawares. On this thread, there is a tension, there is a force holding this meter rule applied at this point, which is 10 cm. Then there is another one too at this point at 10 cm away from this point, and 10 cm away from this point. So from this force and this to this force is 80 cm. And so at that point, I'm going to show you how you will make this to oscillate. Honestly, it is a bifilar suspension. So you are going to do it this way. Sorry, don't allow it to wobble, just do it like this. Anyways, you now use your stopwatch and take reading. Now, how do you take reading? From here to here, from here to here. Like if I hold this thing like this, you see? So, from here to here is 1. 1, 2, 3, 4. That is how you're going to use your stopwatch. It's going to do 1, 2, 3, 4, 5, till 20 complete oscillations. But let's see how this goes. If you have your stopwatch, you can work with me. Very small angular oscillation. Then, so at this point, you can start any point, at any point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You stop. Once you stop, you use your meter rule to measure this length again. This one I did was 40 centimeter. I measured 40 centimeter. I'm going to measure another one from 1 all the way till, okay, from 1 all the way to 50. So I'm going to do the measurement again. So you measure this string again for another 50. You also do the same oscillation. You measure again, you measure here, you measure here. For every length that you measure, all you need to do is to allow it to oscillate for 20 oscillations. Thank you. T-square and which is the unit of measurement I am going to be working with. And on the horizontal axis, I'm going to be plotting h, that is height. And remember, this is the number 1 question. So I have put this, most times in the graph they will tell you and the axis is 0, 0. That means both horizontal axis and vertical axis are starting from 0. So that is the essence of that. Now, the next thing you need to do is to take your scale. What scale is going to suit this graph? And at this point, I have to make a decision how it's going to suit my table. And the table of value, you are seeing it there. What I'm going to do here is that I'm going to call from the table of value that we have. From the table of value that I have, okay, since I have 0.3, so I'm going to say 0.2, 0.3, 0.4, 0.5, 0.6 on the vertical axis. That simply means that I'm trying to check something. Okay, now let me put it this way. This is from, sorry, let me do it this way. 2 cm represents 0.1. This is 0.1, 0.2, 0.1. So I'm going to do this. To cut out that 0.1 was supposed to start, but because of the time, because of the space of the video, I am cutting 0.1 out so that I'll be able to get to 0.6. 20, 30, 40, 50, 60, 70, 80, probably 90. So this is on the vertical axis. Then 2 cm to 10 units on the horizontal axis. So, you know, all this thing you are writing here will give you a mark. This thing you wrote here will also give you a mark. This unit you wrote here will give you a mark. This unit you wrote here will give you a mark. So all these things I have written here has given you some marks for physics particle. So I'm going to plot 40 against 0.36. So this is 40. This is 3. This is 40 at this point. This is 3. But from here to here is 5 lines. So what I'm going to do now is I'm going to find what each of these small boxes represents. Sometimes small line. So I'm going to do a little mathematics, small mathematics there. So see what I'm going to do. I'm going to say if 5 lines equals to 0.1. You understand? 5 lines equals 0.1. Then one line will be what? 0.1 divided by 5. How did I get 5 lines? If you count from here, from 0, 1, 2, 3, 4, 5. That is 5 lines is giving me 0.1. From here to here is another 0.1 because 0.3 minus 0.2 you have 0.1. But what makes this 0.1 is 5 lines or 5 boxes. So I now made it this way. Then I check 0.1 divided by 5. Then one line or a box is representing 0.02. So one line is representing 0.2 centimeter. Sorry, seconds, because I'm plotting second square here. So every line on the vertical axis is giving me 0.02. So I will be that in mind. I will have that in my mind. Same thing happens here on the horizontal axis. If you count, this from here to here is 10. But in terms of the boxes you are seeing here, you are seeing 1, 2, 3, 4, 5. 5 boxes makes 10. Now, in this case also, you are going to ask yourself, how many lines makes that 10? It's 5 lines. So 5 lines is equal to 10. So 10 divided by 5 is 2. Is 2. So each box here represents 2 on the horizontal axis. So we are going to use those things in plotting our graph. Now I'm going to move further. Okay. The next thing I'm going to do is to locate 0.36. 0.36. So t square is 0.36. Okay, this is 0.3. How do I look at 0.36? This is, remember what we call each line here. This is 0.02, 0.02, 0.02. Now, looking for 0.06, you should know that 0. Now, remember when we did the calculation, we found out that between this line and this line is 0.02 from our calculation, because what we did was 5 lines is equal to 0.1. So 0.1 divided by 5 gave us 0.02. That means each line is 0.02. Now, how do I locate my 0.36? This is 0.3 0.3 plus 0.06, because 0.02, 0.02, 0.02, they are all total of 0.06. When we add it together, I'm going to have 0.03. No, 0.36 is at this point. Now, what I'm going to do now is locate this thing with respect to 40. Since this place is 0.36 and this is 40, so I'm going to trace where the two of them meet. This is 0. So this will be coming. This will be coming. They will be coming. They will be coming and meet at that point. So I will know that this is the point where they meet. This is 50. This is 50. And which one is corresponding to 0.423? This is 0.4. This is going to be 42. This is this is going to be 0.42. We are plotting the two decimal places. So 0.42 is this place. So like I did before, I'm only using this to make you understand it. It will move this way. 50 will be coming this way. They will meet there. So 50, I'm using that 0.49. This is 60. 0.49 is 42, 46, 42, 44, 46, 48, 48. This is 0.48. So 49 will be very close to. So at this point, I'm going, because of the graph I'm using, I'm going to plot it somewhere here. So what I'm going to say, under 50 is going to 0.49, very close to 5. So at that point, sorry, I will use the other part, the other pattern I love to use. So that is it. Of course, you see what the graph is coming into. Under 70 is 5.6. Under 70 is 5.6. Under 70, 5.6. This is 5. 5.6 is going to be 5.2, 5.4, 5.6. 5.6 is here. Under 80 is 6.4. Under 80 is 6.4. This is 80. And this is 6. 6.4 should be 6.2, 6.4 is going to be somewhere. So that is it. So change in this square, that is from here to here. The distance from here to here is that this highest point minus 1 point on the vertical axis. While this one minus this, people used to say rise over run. Rise over run. So rising and running. Running is, this is the highest point, and when we did this, we said that 5 lines. We said that 5 lines represented 10. Therefore, 1 line is going to be 2. So this is 82, 84, 86. So it's going to be 86 minus 30. So this is going to be 0.38 over 56. Therefore, the slope I'm going to write the answer here. Therefore, the slope is equal to 0.38 divided by 56. So 0.0067 68. Now, on the vertical axis, we are plotting x square all over. On the horizontal axis, we are plotting centimeter. That is right. So the SI unit of the slope is times square, that is second square per centimeter. And this is your slope. And remember, there is something we call line of best fit. I will not forget to tell you that. If you look at this line, 1, 2, 3, 4, enter. So there was no stress in considering the line of best fit. So everything here is okay. When I'll be doing the other experiment on electricity and the other one, then I'll be able to, if we have such issue, we'll talk about it. So this is basically what you are going to be expecting for graph 2021 physics practical for number 1. And I'm sure you understand. If there is anything you don't understand, please don't forget to put a comment below so that I'll be able to tackle one of the issues. And remember, don't forget to subscribe.